Hey Dr. Co, let's talk about a bar. So in our problem, our bar is 50 meters long. The bar has an initial temperature of 20 degrees Celsius across the entire bar. The thermal diffusivity is 1 meter squared per second. And the left side of the bar is rapidly heated to 50 degrees Celsius. The right side of the bar is is uh, is perfectly insulated. So what this means is the temperature at the right side will be the same past the end of the bar because it won't change from then. This will help us later because the temperature, we're going to say that position J, J plus 1 at the end of the bar is going to be equal to J. Okay, so let's start with the Crank-Nicolson equation, which is the temperature at the current position at the next time minus the temperature at the current position at the current time divided by the change in time is going to be equal to the thermal diffusivity over 2 times the change in x squared times t. This will be the position to the left at the current time minus 2 times the position to the current position at the current time plus position to the right at the current time. This will be taking the average between the position or to the all the temperatures at the next time, the position to the left, the current position at the next time, and the position to the right at the next time. It's taking the average, as you can see, the two, adding them together and then dividing by 2 will be the average of between those two. If we use our R value as equal to the thermal diffusivity times change in time over 2 times change in x direction squared, we will get a simplified version of the equation that we can simplify further to this. We want to get all of the values at n, which will be the current time, on one side. We will put those on the right side of the equation, and then all the values of n plus 1, which will be at the next time interval, we want those on the next side of the equation. By doing that, we will be able to split them up later to help us solve for our unknown temperatures along the bar. So from here, we'll move all of the t at a position, n plus 1 to the left side, and the t at the position, and then at the current time to the other side. So we'll start with this right here. It'll be j minus 1. It's multiplied by the r, and it moves to the other side, so it's negative. Then we'll have plus 1 plus 2r, because this term and this term will combine when it's moved to the other side to 1 plus 2r, t at the current temperature at the current position at the next time. And then it'll be minus again r with this. So that's a plus right there. This right here. And this will be at the position to the right. And then that'll be equal to r times, that'll be this right here to the left, and then the current time, because that's what we want on this side. That'll be plus 1 minus 2r, because we have this right here, and this term will, that'll be t at the current position, n, and then it'll be plus r, and then that'll be the current time, but the position to the right. Now that we have this equation, we can start to make our vectors in our matrix. So we're first going to make the coefficient matrix. So this will include all the coefficients on this side of the equation. That'll be like our negative r and our 1 plus 2r. So right here we know what this will be because we're given a current or a temperature at the start. So we'll start with the 1 plus 2r. Then to the right, it'll change to negative r, and then from there on out, it'll be zeros. So we'll move on to, because this is at j is equal to 0, then j is equal to 1. We'll move on to the next, and then from there, it's j n. And then next, we'll move on to, it'll start at negative r, because we'll be able to include this. Then it'll be 1 plus 2r again, and then negative r, and then 0, because the rest of them will be 0 from here. And then the next one will be, it'll start out 0, and then a similar pattern will continue on until finally we get to our last line where it'll also have negative r here, but this will turn into 1 plus r, because if our position at the end is equal to the next position, then this will cancel out the 2 right here, and it'll just be 1 plus r. Next, we can move on to the vector of unknown t values, and that'll be the vector of all our tn plus 1. Tn plus 1, and that'll be at like our position 0, 1, 2, and then n all the way on down. Next, we can move on to the vector of the t equations. So from here, we'll use this right side. The first and last lines of this vector will be a little different than all the middle lines. So our first line, it'll be like this. We'll have the r times the temperature, and this will be the temperature to the left of the current position. Then it'll be plus 1 minus 2r. That'll be like at the position 0, because it's our 0. And then n. Then that'll be plus rt, and that'll be the position to the right, or position 1, n. And then we know this value right here, so we'll add it to the other side, and then it'll be plus it right here. That'll be plus t. It'll be at j, or j minus 1, so it'll be left side n. And then that's our first equation. The rest of the equations will follow more suit to this, except for the last one. It'll be tj minus 1 at the current time, plus 1 minus 2r t at the current position, temperature at the current position at the current time, plus r temperature to the right at the current time. That'll continue down until the very last equation. So right here, because these are equal, we will know what this is right here. So when we add that to the other side, they'll be equal. So before we add that to the other side, we will know that this will cancel out this 2. So it'll be rt, and then the position to the left at the current time, plus, and then this it'll be 1 minus r instead of 2r, because that cancels with that, because they'll be equal. And then we'll add this to the other side, because we'll know what that is, because it'll be at the end, and it'll be the same as the j. And then now that we have this, it'll be able to cancel out the second r, so it'll end up being tj to the left, or r times the temperature to the left at the current time, plus the temperature at the current position at the current time. So now that will fill in our final line. Now that we have the matrix And these two vectors, we will be able to plug this into Python and solve for the unknown temperatures.